How's it going, everybody? And welcome back to our Cisco Enterprise series. In this video, we are going to be diving into multi-area OSPF, where you and I are going to talk a little bit about how multi-area OSPF works and how that gets into play and stuff like that, so that we can see how it will optimize our environment a little bit. We can see how stuff like this is going to work, and that'll allow us to do more interesting things like stub routing in some follow-on videos after this. So the concept of stub to breaking up an OSPF deployment into multiple areas is to cut down on the amount of SPF runs that you have to do per area. Right now, everything that we have in our environment now is in one big area, right? Area 0 is everywhere. Now, anything that's doing any type of layer 3 routing, we have it's applied to an area 0 configuration. Now, it's actually supposed to be OSPF, but whatever. So when we talk about multiple areas, we have to understand that the concept of multiple areas is very, very simple. If you want to control your OSPF database and you want to control your routing design a little bit more thoroughly, there's only two ways that you can do that. Either at the edge of the network, where you're doing some sort of redistribution and you're doing external summarization, or at a area boundary, so an area border router. Now, the way that this is typically going to work is you're going to be doing this on a per link basis. So what you would normally do is something like this. Is right now everybody's in area 0. So for the sake of argument, I'm just going to draw a big circle around everybody. All of this stuff is one big area. Okay? So that means that there's a problem here, everybody's going to know about it. Whether it's a link down, what have you, router reboots, whatever it might be, everybody's going to learn about it. Now, it's small topology, right? There's not a lot going on. May not be a big deal. Now, think of this as a much larger environment with lots and lots of devices. Potentially could be a problem. So how would you go about doing this? Well, I kind of already done the hard work for you, and what I'm going to be doing is taking all these little rectangles and squares that I've drawn around all the hardware, and we're going to be basically using that as our area design. So what I'm going to do here is we're going to make this area 0, because this is our core, right? And that makes a lot of sense for the most part. So let me draw square. Can I do rectangle? Perfect. And then I will do this will work. So we're going to draw, this will be area 0, right? And then what we're going to go do is we're going to have other areas. So we're going to make this guy right here, we'll make this area, let's make this area 10. And then we're going to do sky blue, then this will be area 20. And then, actually, we'll make this area 10. This will be 20 because the subnetting. And then what I'm going to do is we're going to change the color on this one again to be, let's say, orange. This will be area 30. And this will be, let's do a blue. This will be area 40. Okay. And by doing this, you'll be doing this on a per link basis. So what we'll do is we will go and have to optimize our routing from the perspective of the configuration. So for the most of the routers, we did a blanket 10/8 for area 0. Very simple design. Now what we're going to end up doing is we're going to convert this, and we're going to get more specific with our routing design. So we'll go underneath the global configuration for OSPF. We'll type in network of 10.25.51.0/24 or 0.0.0.255 for a wildcard, and then we're going to put this into area 20. Same thing with this one. So this connectivity right here will be area 20. Now, technically speaking, when you do this, what will end up happening is we'll actually be moving this. Can I erase this? What will end up happening is you'll end up having it something more like this. Okay, because you're going to have R25 and XR41 on gig 03 and gig 02. They will also be in area 20, and that'll be extended down to here. Okay, and the same thing will happen for VLAN 10. VLAN 10, this blue line right here will actually be part of XR41 and Nexus 49, and so on and so forth with switch 13 and switch 14 will have their particular areas will be attached to these interfaces on 57 and 49. So the extension is actually overlapping in a respect. So this drawing is more accurate to how IS to IS would do areas, because you can't have a IS to IS router in more than one area. So as part of the network entity title, you'll see that later on when we get into IS to IS. So what I'm going to do is I'm actually going to go ahead and clean this up a little bit. And since I already know where we're going to be doing this, I'm going to scoot up a little bit and get out of the way, and we're going to go through and do a basic configuration of how this is going to work. We're going to start on R25. Configuration wise, it's very, very simple. If you do show run pipe section OSPF, you're going to see that we're doing a blanket 10/8 area 0. So to change that, we're going to break some configuration. I'm going to type in router OSPF 1 and type in network of 10.25.51.0.0.0.255 area 20. Okay, now it's going to take down the adjacency because the adjacency is already in area 0 now, and it says that we move this from area 0 to area 20. And then we have it's telling me now that received invalid packet mismatched area ID from backbone area 51. And it's going to continue to squawk until I fix this. Now we go to 51, we're going to see the same thing. We're going to see that received wrong area, area 20, right? So in order to fix this, we have to go to show run interface eth 1/5. We're going to go to global config. We're going to go to interface eth 1/5 and type in IP router OSPF 1 area, and we can put this in as 20. Okay, I'm going to flip that over. And so the adjacency should be full again. And now as soon as I do this, and I do a show IP route, what you're going to end up getting, and Nexus has a weird way of laying it out because Nexus is just, it's a data center protocol or data center platform. You're going to see this inter, meaning that it's an inter-area route. Okay. Now, if I do this on say XR41 and switch 7, it's going to look a little bit different. So in XR41, I'm going to go ahead and log into this guy. I'm going to do show run router OSPF. And then what I have to do, first thing I have to do is I have to go underneath router OSPF 1, underneath area 0, and type in no interface gig 0000002. And then I have to go underneath area 10 and apply that. So we do a show config. I'm going to go ahead and say point to point. Network is point to point, so that we keep that operationally in place. I'm going to go ahead and I'm going to commit that config. So config took, do show run router OSPF. We can see that that is still there. We have a mismatch area ID. Switch 7 is probably squawking, saying, "Hey man, there's a problem here." Well, actually, it hasn't been long enough because we got to wait for that dead timer. Show IP OSPF neighbor. We're going to see that dead timer starting to go down to 12. So this will take a little bit of time for it to fail. I'm waiting for it to fail. So now it's been init to down. And if we go to global config and do show run pipe section OSPF, what we're going to go do is at the interface level, so we're going to say do show IP interface brief, interface gig 1/1. I'm gonna go. I've shown you both ways now because Nexus forces me to show it to you the other way. I'm gonna go to router OSPF1 and type in network 10.7.41.0 0.0.0.255 area 10. Now that's going to change it, and then because it's going to be in the same area, we should be able to form an adjacency, which we do. And now because of that, I'm going to do a show IP route. And as soon as OSPF finishes reconvergence with SPF, we should start to see a bunch of routes show up. This is what I wanted you guys to see. I wanted you guys to see the OSPF inter-area route. Okay? So that's essentially what we have in place now. So because we have that in place, we're at a good spot, right? We can go ahead and go forward with other operations and things like that. In other words, if we want to do stub routing, this would be a great place to start doing the stub. Now, the idea now would be to basically finish the process on all the other devices. So I'm going to do the exact same thing that you've seen what it looks like on a couple different devices. Let's go ahead and wrap this config up. So we're going to go back to 41. And I'm going to go underneath area 0, no interface, gig 00003. And then we're going to type in area 1, or area 10. I'm going to put in gig 3, and I'm going to commit that. We're going to go over to Nexus 50. Log into him as well. Show run interface eth 1/5. And we're going to copy this config in right here, but we're going to move this to area 20. So that's been put in a different area. Wait, did I put it at 41? Oh, I put it in the wrong area. That's my fault. So I'm going to go to my mistake. No area 0, and then area 20. Commit that. That should fix that problem. We'll see a merge. Now you're seeing this other one here. Received invalid packet, mismatched area ID from backbone area, must be virtual link, not found from 10.4.41.50.50. The concept of virtual link is an extension mechanism. We're going to talk about that in a little bit, but the idea with a virtual link is you're trying to run a connection from one device. You've got discontiguous areas. Remember, all non-zero non-backbone areas must connect to area 0. That's the rule of OSPF. Well, if you go in linear, you go routers 1, 2, and 3. If you get router 1 in area 0, router 2 in area 2, and router 3 in area 3, that's a problem. So you would end up using area routers 1 and 2 to form a virtual link so that router 2 that has connection to area 3 that router 3 is in extends area 0 down to that ABR. It's kind of a use case, but a weird use case, but it does get the job done. We'll talk more about that later. So now 50 should be in pretty good shape. So if I do show IP route, we should have momentarily, show IP OSPF neighbor. Show run interface eth 1/5. Area 20. 41 should have it there as well. So do show run router OSPF. Oh, I'm not doing the network point to point. That's why. Network of point to point. And E15. That's why. Because we're in the same area. So we have that. It's in area 20, point to point. That's correct. 41. Oh, commit. That should fix that. Even though there it goes. Kind of a weird conundrum that we were in. Interface, correct. Neighbors, there we go. So show IP route. Now we're starting to get the routes. There we go. Okay. So that puts us, this set of connections is in area 20 right here. And then we're going to have, and once this is all done, we're going to go ahead and I'll adjust the rectangles and the breakouts to represent the new area design. So we're going to go to Nexus 49, and we're going to move him. We're going to say interface ETH 1/3. We're going to type in IP router OSPF 1 area 10. And then we're going to do the same thing on switch 8. He's way over here. We're going to go do show run section OSPF router OSPF 1 network of 10.8.49.0.0.0.255 area 10. So we're good to go there. Cool. So do show IP route, and after OSPF does its run, there it goes. We are in good shape. All right. So now that we've got that one done, we've migrated. Actually, go ahead and take a quick second here, and I have to adjust this. Let's scoot this over just a little bit and up. So it'll essentially just be these interfaces right here, the internal facing interfaces. Those are the ones that'll be in area 0. Everything else will be in another area. So this one here will be, can I move this over and move this up? Just so I give myself a little bit of breathing room. And then we'll take this guy here. This essentially will be the new connection, just like that. Then I'll move this back to here. And then, actually I want to move this over just a little bit more. Too bad there's not a way to bring this in, but I might have to bring these down and move this up, but you get the point. So actually, let me pause real quick. All right, so this is more or less the direction I was trying to get to, but I'm not sure if this is such a great idea. I might just go through and draw it out a little bit differently, just so at least you guys have a visual. So, but anyway, for the moment, it makes sense based off what we're trying to do. So this will be more like this. So that's going to be how that would work. So this will be area 20, this is area 10, this is 30, this is 40, and then this guy right here would connect down to both these guys, this guy would connect to both of these guys on these interfaces. So you get my point. It just, it makes the logic more challenging to draw out, but if you understand what we're doing and where we're doing it, if you're following along, then that's the key thing that I want you to take away from it, is the routers that are making up area 0. So 25, 57, 41, and 49, they make up area 0, right? And then because they have connections off on different interfaces to different routers that we're putting into different areas, those are going to be the interfaces that we have to migrate to different areas. Configuration-wise, you can see it's very, very simple, right? You would obviously do this ahead of time when you're first standing up the environment. You wouldn't do this like mid-deployment. You could, but it would be highly suggested that you think about this stuff from a design perspective before you get to this point. So let's go ahead and finish the config, just so we have all this stuff taken care of. So I'm going to go to switch 13 and make my config changes there. And we're going to type in all the 10.13 is going to be in area 30. So do show run section OSPF. So router OSPF 1, network of 10.13.0.0, 0.0.255.255, area 30. That's how that's going to work. Now, one thing that I haven't talked about yet is going to be all of the SPIs and all that other type of stuff. We'll talk about that here in just a minute once we get it all figured out, because we're going to test reachability. Okay, so we're getting those errors from 57 and 34 and 33, so we're going to have to fix those. So technically speaking, all these interfaces should be in area 30, which they are. So we're going to go to 57. Let's go to 33 real quick. We're going to go to router OSPF 1, network of 10.13.0.0, 0.0.255.255, area 30. Do show run section OSPF. We're going to literally just take this line of config over to 34. Paste that in. Alright, so now we have that done. Let's go to switch 14 and do the exact same thing. We're going to type in router OSPF 1, network of 10.14.0.0, 0.0.255.255, area 40. So that's going to break a lot of stuff. So let's go 58 and 59 and configure those as well. Router OSPF 1, network of 10.14.0.0, 0.0.255.255, area 40. Do show run section OSPF. Go over to 59 and configure him the exact same way. That'll fix that. So we're in good shape there. Okay, so now that we've got that done, now we got to go to 49 and 57 respectively and adjust those interfaces. So let's go to 49. This is Nexus. We're starting to get a lot of squawking here. So we're going to go to E14. It'll be IP router OSPF 1 area 30. And then E15, we're going to go area 40. So that should fix that. And then on 57, same thing. Router OSPF 1, network of 10.13.0.0.0.0.255.255, area 30. And then we'll do the same thing with 14, area 40. Just like that. Okay, so now we've got that all squared away. Now, what do we do about everything else? We have SPIs that are in the wrong subnets or in the wrong areas, that type of stuff. So if I go to 50, I'm on 57. I'm sorry, I want to go to 50. Let's go to 58. And let's see, can we see a VLAN 10? Show IP route. Do I see VLAN 10? Nope, sure don't. VLAN 10, VLAN 11, they're missing. Why? Well, simple answer is this. If we go back to switch 7, we look at switch 7's config, show run pipe section OSPF. Because we've manually moved just that one subnet into area 10, just the point-to-point link, right? Move this into area 10. But the SPIs are still in area 0. So how do we fix that? Well, the simple answer would be to go back to OSPF. We can either go to the SPI level and type in, you know, IP OSPF 1 area 10 and be done. So let's do that on this one. We'll type in interface VLAN 10 through 11. I didn't think that, or I might have to do range. VLAN 10 through 11. Aha, IP OSPF 1 area 10. So that should fix that. So let's go back over to, let's say, let's look at 33. Do show IP route. Do I see the 10 networks now? You betcha. Right there. So what I'm going to do on 8 is I'm going to do a little bit differently. Show run section OSPF. We're going to type in network of 10. Router OSPF 1. Network of 10.1.10. Actually, it was just 10.1 0.0 0.0.255.255 area 10. Does the exact same thing, right? So we move those subnets over to area 0, from area 0 to area 10. So they're in a good spot. So now if I go back to, say, 33 again, and hit the up arrow, we're not actually going to see any update because we've already had them from switch 7 propagating. But the bottom line here is we should see it both. Now if I was to do a show IP OSPF database, we should see this right here, but notice how where it's coming from, the originating router is 57 and we're on router 33. Now I haven't talked about how the OSPF database updates when you've got different areas. We're going to talk about that in the next video because we're already half an hour into this one. I need to go over to Nexus 50 and 51 and update their config, and then all the loopbacks actually have got to get moved into here, because if we do a show IP route, what you're going to see is you're not going to see any of the 10, well, some of them you will. 13, 25, you'll see some of them, but you're not seeing 50, 51. You see some of the loopbacks, but you see the ones for switch 13. You see them because they're in area 0. It's propagating correctly. So you see that's okay, because this is technically part of an OSPF domain. So normally what I would do in that particular case here, switch 13, if I do a do show IP OSPF interface, do show IP OSPF interface brief, what you're going to get is you get this loopback is in area 0 still. So let's go to interface loopback 0 and type in IP OSPF 1 area 30. And then we'll do show run interface loopback 0. Some of these devices are going to be easy to do. Some of them will not. Let me go ahead and get out of the way. So on 14, we're going to go to interface loopback 0, IP OSPF 1 area 40. And then we're going to go to 50 and 51. We're going to go to interface loopback 0, IP router OSPF 1 area 20. I'm going to take these two lines of config, copy them into N51, just like that. And then for switch 7 and switch 8, I'm going to do basically do the same thing. So do show run interface loopback 0, interface loopback 0, IP OSPF 1 area 10. Same thing on switch 8. Interface loopback 0, IP OSPF 1 area 10. Did I not create a loopback 0? I sure didn't. Interface loopback 0, IP address here will be 10.0.0.8/32. do show interface loopback 0. Good. Save that config. Let's go to 7 and do the same thing. I really do need to make a habit of saving my config when I'm done with the video, so I don't have to reconfigure stuff. So anyway, we're good to go there. So now everybody should have reachability to everybody else. So if I was on switch 7, I do a show IP route, I should see 8, 13, 14, 25, 41, 50, 51. Okay, so I'm missing 57. I'm sorry, missing 49. No, 49 is there. 58 is not. 59 is not. And neither is 33 or 34. So I gotta go, let's go over to 33 and show run pipe section OSPF. So we can see that we moved, we still have, and this is one of those things why I'm pointing it out. Because here we are on switch 7 and we see that we're missing 33, 34, 58, 59. So because those loopbacks are still inside of area 0, configured to be inside of area 0, and they're not on a area 0 enabled interface, or I'm sorry, they are on an area 0 enabled interface, but not connected to the backbone in any way, it doesn't get advertised. So this is one of those things where you have to take that into consideration when you're doing your config. So interface loopback 0, IP OSPF 1 area 30. And the same thing on 34. Interface loopback 0, IP OSPF 1 area 30. And then 58 and 59 will follow suit. Area 40. Okay, now that we've done that, let's go back to switch 7. Switch 8 will work too. Show IP route. So now we should see, I see 7, 8, 13, 14, R25, R33, R34, 41, 50, 51, 50, 50, 51, 57, 58, 59. I think that's everybody. It sure looks like it. Okay, now that we've seen all that, we are in a good spot from an operational perspective. Now what I'm going to do is I am going to go through and I'll probably take just a screenshot of this just so that we have a reference diagram as we move forward, as we continue moving forward in other videos. I'm going to go ahead and move this back because my OCD is triggering, just so that it makes more sense as we're moving forward. Basically going to put this back. Obviously not with you guys in the video. And then once we do that, then you and I are going to go through and take a look at observing the Linksy database as a type with multi-areas and see exactly how that comes into play and how that works. So if you guys have any questions, comments, concerns, feedback, drop a comment in the comment section below. If you haven't already done so, please like, share, and subscribe, and I'll catch all of you fine people in the next video.